All right, everybody, so we're going to go ahead and get started. Once again, my name is Jonathan Garbin with VoIP Supply. We also have Abdel from Grandstream on the line, who will be giving the majority of the presentation. For those that just joined, there's a Q icon in the lower portion of the screen in a little speech bubble. If you have any questions throughout the presentation, feel free to submit them there. I will be managing that as those come through, and then I can pass them along to Abdel as questions come up. But for me here at VoIP Supply, we were founded in 2002, so just recently celebrated our Sweet 16, one of the first companies to really take the jump into the VoIP world. So we're one of the oldest, most experienced companies out there for VoIP. 30+ employees, myself, and about 5 or 6 other people make up the sales team. We have handled over 125,000 customers worldwide, and then obviously located in Amherst, New York, which is just outside of Buffalo. So if you have any questions, give us a call there. And just a quick note about our partner program or reseller program. Big one was we recently put together a rental program. Tied into with NEC, their finance department, we're able to put forward rental options for you and your customers. Makes it a pretty awesome option for you in case you don't want to throw a bunch of money into a big one-time investment. If you want something that you can get some recurring revenue off of, that's a really great program that we just started up and have had some success already on that. In addition to that, hardware, obviously we sell Grandstream, one of our top manufacturers that we resell. Experts, like I mentioned, 5 or 6 guys on the sales team. We've all been in the IT world for 5 years at the lowest, and 15 years dating back to guys that started with the company VoIP Supply when it first started. Cloud Marketplace is a place where we resell a bunch of VoIP cloud providers and SIP trunk providers. So if you, as a reseller, want to resell them, those different providers, we can definitely work with you on that and pay a commission on that. Fulfillment, we can manage, provision, and ship everything in-house for you if you don't want to take on that yourself. So let us know if you want to do that. And then refresh, reclaim, where we can buy back old VoIP equipment, and we also resell it in our own internal refurb brand called Refresh. And yeah, just like I touched on the Cloud Span Marketplace, no quotas or commitment levels, best-in-class commissions, usually starting around 15%. Obviously, a lot of things have come to the cloud, and it's an area of VoIP that's only growing. So we've got a lot of traction on that. We only partner with some of the top VoIP service providers. So a lot of great opportunity there. If you have any questions, let me know on that. And that's me right there. Becoming a VoIP partner, VoIP reseller, happy to help you out. We do net 30 terms, a lot of different that we can accept shipping account numbers. So a lot of different ways that we can kind of help grow your business through VoIP, through Grandstream, and then with VoIP Supply. And then I think that is it. But yeah, without further ado, Abdel from Grandstream, why don't you take it over here?
All right, thanks, John, and thanks everyone for taking the time to join us in today's webinar. As far as the agenda for today, we'll briefly introduce the Grandstream IP telephony portfolio in case you are not familiar with the Grandstream IP phones. Then we'll talk about VoIP fundamentals and give an overview of what SIP is and how it works using call traces. We'll also talk about how to secure SIP signaling and media stream using TLS and SRTP respectively. Then we will finish up with a live demo to show you how you configure secure SIP and SRTP on both the phone and the UCM. All right, so let's get started. So this slide shows us the Grandstream IP phones portfolio. So from top to bottom, we have the GXP 3200 series video IP phones built on Android. And I would like to introduce the latest product released by Grandstream, which is GXP UCM3370, which runs on Android version 7, and it supports 16 lines with 16 SIP accounts and many other advanced features like dual band Wi-Fi, 7-way audio conferencing, 3-way video conferencing, built-in Bluetooth, plus API SDK for advanced custom application development. And next we have the famous GXP 2100 series that have color LCD displays with virtual MPKs. Some models like the 2140 and 2170, they support optional expansion modules for MPKs as an accessory. Then we have the mid-range GXP 1700 series and the basic IP phones GXP 1600 series, which are a good solution for those who handle low to medium call volume and require access to pretty much basic call functionalities. So this is the UCM, the Grandstream IP PBX appliance. So we have the UCM6200 series, which comes in 3 models, 6202, 6204, and 6208. The last number just indicates how many FXO ports does the appliance have. So in case, for example, you have clients with, I would say, 7 POTS lines that they want to use with the IP PBX, you want to go with the 6208 because it provides you with 8 FXO ports. All the devices, all the IP PBX appliances, they come with 2 FXS ports with lifeline capability. This is useful in case of emergencies. So when the UCM or the IP PBX loses power or loses internet connection, you can still connect to one of the analog phones to the FXS port, and with the lifeline capability, the analog phone connected to the FXS port will still be able to make outbound calls through the FXO port, even if the device is not powered. So for the 6202, that one supports 50 concurrent calls, the 6204, 75 concurrent calls, and the 6208 supports up to 100 concurrent calls. The 6208 can support up to 800 SIP endpoints. The next series of the UCM that we have is 6510. This one, besides the hardware capacity and the memory capacity that it has, the major difference is that the 6510 comes with an E1, T1 ports that you can use in case your customer has a PI. This device also comes with 2 PSTN ports, FXO ports, and 2 FXS ports. This device can support up to 2,000 SIP endpoints and can handle up to 50 SIP trunks. So before we get into the signaling and media protocol involved in the multimedia session, I will briefly talk about the benefits of VoIP. VoIP or voice over IP basically allows you to send and receive audio and video stream over the internet. So when compared to the traditional POTS circuits, VoIP has exceeded in providing more benefits. Some of these benefits, I would say, is the cost, because VoIP reduces the cost of communication. So instead of having dedicated expensive circuits for multimedia, VoIP uses the network infrastructure that is already available in your network without the need to run more cables. There's also the benefit of mobility. So regardless of where you are, you can always use any supported mobile device to connect to the company phone system and make and receive audio and video calls. Then there's also the advantage of application integration. So VoIP devices can take advantage of the latest technological advancements like HD video conferencing and integration with other systems like CRM, CTI, and mail servers, LDAP servers, and a lot more. So these are only a few. There is still a lot more to talk about when it comes to the benefits of VoIP. So Grandstream has actually exceeded in including all the VoIP benefits into its solutions. So when talking about the application integration, for example, Grandstream solutions now provide a collection of technologies and services like CTI, CRM applications like Salesforce, Sugar CRM, integrated also with the PMS systems like H-Mobile and Mitel, plus other services like LDAP, fax over IP, and WebRTC. Grandstream solutions also provide with the mobility, so wherever you are, as long as you have an internet connection, you can always connect to your company's phone system to make phone calls, video conferencing, or even share a presentation. So in today's presentation, I will focus primarily on
one quick question on that, on video conferencing. We have Kurt who wrote in regards to the GXP 3370 and the 7-way video conferencing. Does this mean that it has its own MCU built in?
Yes. All the GXP phones, they have an MCU, and they provide you, when it comes to video conferencing, with 3-way video conferencing and 7-way audio conferencing. I hope that answers the
Awesome.
question.
Thanks so much.
So the focus of today's presentation is going to be the signaling protocol, session initiation protocol, or briefly SIP. So despite the fact that there are a handful of other signaling protocols currently used in the VoIP industry, SIP remains the most common one used by major VoIP device manufacturers and suppliers. Some of our devices will support H323, and the only device I believe is the GVC3200, the video conferencing devices. These are the only devices that support H323. But for today's presentation, I will focus mainly on the SIP protocol. And all other devices, Grandstream devices I mean, are SIP-based and should be compatible with any platform or endpoint that supports SIP. So technically speaking, SIP is...
Sorry, Abdul. Question just came in regards to platforms. What sort of integration does Grandstream have with Microsoft Office? So
Microsoft Office, now you can use it with the mailing services and business Skype for Business. I mean Office, yeah, that's only mailing services on the UCM. So this is something that applies only to the UCM. So going back to signaling protocol SIP. So SIP is a signaling protocol that is used to set up, modify, and terminate call sessions over the IP network. So it is a standard defined by ITF, or the Internet Engineering Task Force. It is not proprietary, which means it is not restricted to any vendor or supplier or VoIP services. Anyone can use it as long as it is implemented according to the standard requirements. So SIP is not dependent on the transport protocol, I mean the transport layer. You can configure SIP to run on either UDP or TCP, though usually you find it run on UDP. One thing about SIP is it is text-based, so anyone using packet sniffer on the wire can read the content of the SIP messages exchanged during the multimedia session. So the following image depicts how a multimedia session takes place. So I'm going to stop here for a few moments to further explain each step involved in the call initiation, control, and termination. So in our example, we have Alice. She's using her GXP 2130 to make a phone call to Bob through the UCM6200, which will facilitate the call session establishment. So these are the steps involved in this process. So for Alice to call Bob, Alice needs to send the request to the proxy server. In our example, it's the UCM6200. And for that purpose, Alice will use the SIP invite method for this request to establish the call. The invite message, as you can see in the screenshot on the side, this is taken using a Wireshark. The invite message includes several headers that serve different purposes. So looking at the capture from Wireshark, we have the from header, which identifies the endpoint that wants to initiate the call in the SIP URI format, similar to the one used in the email addresses. This header can also include the caller ID name that the endpoint wants to send. So in the example, we have Steve Common, and his caller ID number is extension 1005. Next, you have the to header, which specifies the destination of the call. There is also the contact header that includes the SIP URI at which the endpoint can be reached for future requests within the same dialog, plus other information. There are actually many headers that you can include in the invite. Some of them are proprietary, like the one that you see, X Grandstream PBX True. So as mentioned in the previous slide, SIP works in conjunction with SDP, or the Session Description Protocol. So while SIP deals with setting up, controlling, and terminating the call session, SDP, the message or the body message, or the message body, sorry, uniquely deals with the media details. So some of the information that is included in the SDP message body is related to the type of codec, for example, supported, and also the transport address. So in other words, the SDP message just tells the recipient, in our case is the UCM, the media types that the SIP endpoints, the GXP 2130, supports. And the UCM can choose one of these codecs and then use it to compress and decompress the voice data. So in case the recipient, or what we call the user agent server, which is the UCM in our example, does not support any media type included in the SDP message, the call will not be established. So looking at this example at the bottom under the message body, you will see that in the invite message, the GXP of Alice sends a lot of codecs that it supports, and some of them is the PCMU or G711. Then you have G723, G729, G722, and ILBC, and G726, and Opus. And it also includes the DTMF method that is used by the SIP endpoints, which is the RTP event. We'll talk more about the codecs in the next slides. So going back to the call flow that we have in the image. So when the SIP proxy or the IP PBX receives the invite message from Alice, before it processes the request, it needs to authenticate the sender to ensure that it is not a log endpoint. And the way that works is through the challenge the IP PBX sends to the SIP endpoints or the GXP 2130. This is illustrated in the message 401 unauthorized. 401 unauthorized does not mean that the server is rejecting the call, but the server is just challenging the GXP phone for authentication. And the way the UCM challenges the user agent client is by including the nonce, which is a randomly generated number in the challenge, together with other information. And the GXP 2130 will use the nonce, which is the randomly generated number, together with the SIP password that you configure on the device and generate a hash using MD5 and send it back to the UCM in the second invite message. So when the UCM receives the hash, it will compare it with the one it has already generated using the same nonce. If it matches, the UCM will process the invite request, and it's going to send 100 trying to indicate that it's taken care of the request to initiate the call. So all of this actually happens in a fraction of seconds. So you don't feel it; you can only see it in the traces. So when the UCM starts processing the invite, I said it will send a trying message to the user agent or the GXP phone. Just a way to tell it, hey, I'm taking care of your request. Then the IP PBX will try to establish the call with the remote party, which is Bob's phone, and process the invite message. So when the destination phone receives the invite message, of course, after it processes the message, it will start ringing. And at the same time, it will send the provisional message 180 ringing. And the UCM will forward this message to the call initiator, which is Alice. So when Alice receives the 180 ringing message, the GXP phone 2130 will generate the ringback tone. So just so you know, the ringback tone is most of the time when there is a 180 message is generated by the device itself, the device that you're using. So after that, when Bob picks up the phone, his phone will send a 200 OK with an SDP message to confirm the codecs that they're going to use for the multimedia session, and also a way to confirm that the call has been answered. And the UCM must acknowledge the reception of the 200 OK and forward the same message back to the GXP phone of Alice. So when Alice GXP phone receives the 200 OK, it will stop playing the ringback tone and start sending immediately the media stream or the RTP traffic. So as I mentioned, the 200 OK message also includes the SDP message, and the phone will use the transport address and the port number in the 200 OK SDP message to start sending RTP traffic to Bob. So with acknowledging the 200 OK, the SIP session establishment has completed successfully, and RTP or real-time transport protocol will take over. And RTP, by the way, is the protocol that is used to carry and deliver the audio stream. I will explain RTP and how it works in the next slide. So finally, when the call is over and Bob hangs up, the phone will send a bye message to indicate that the call has terminated. So that was just a brief explanation of the basic steps involved in the I would say the SIP process. There is still a lot more to learn about SIP. There are multiple RFCs that are related to SIP, and they are all available on the online if you would like to read more of them and get more knowledge about SIP. Because I believe that everyone who is in the VoIP industry should have at least a basic understanding of how SIP works. So one of the things that we learned from analyzing the previous SIP trace is that all information is exchanged in plain text format. This can become a security issue when confidentiality is required, because someone with access to the network and with a packet sniffer can capture these messages, read them, and eventually use that information for other malicious purposes. This is when secure SIP becomes useful, because it allows you to send SIP messages in an encrypted format using TLS, which eventually protects against eavesdropping and data tampering. So, as I mentioned, secure SIP runs on TLS, and it uses certificates for authentication and encryption. And I'm gonna explain those certificates and what they serve when we go to the live demo on the GXP phone and the UCM. So this is another call trace using SRTP. So when the SIP endpoint or the GXP phone, for example, sends an outbound request to the UCM to open a TLS connection on specific port number, by default, the UCM or the Grandstream devices we use 5060 for SIP and 5061 for TLS. An exchange of message will follow up. So from the call trace displayed, the phone will send client hello message. This message includes the TLS version that is supported by the SIP endpoint and the cipher suite supported also by the phone. Then the UCM responds back with the server hello with its supported TLS version and cipher suite. And then the TLS handshake takes place and the two endpoints exchange the public keys that will be used for encryption together with the CA for authentication plus some other information. So when the exchange completes successfully, the encrypted data will start flowing in both directions. And what I mean by the data, I mean the SIP related data, not the RTP data. So I mentioned that SIP is responsible for creating, modifying, and terminating multimedia session. However, it is not used to deliver the voice data end-to-end. And we also mentioned that the RTP that is responsible for delivering voice data between SIP endpoints. So to further explain what RTP is and how it works, RTP runs on top of UDP. So RTP by itself does not support any mechanism that I would say that guarantees timely and reliable delivery of data, because RTP main task is speed of delivery. It was not designed the same way as TCP because of the nature of voice traffic that requires real-time transmission. So let me go back to the previous trace because it has an important information that explains how RTP is used to deliver the voice data. So this one, I believe. So the purpose of the attribute that is marked with a yellow arrow is that when you are talking during the phone call, your phone or your SIP device needs to divide the audio chunk. And the attribute is called p-time equal 20. 20 stands for 20 millisecond. So they agree every time you talk on the phone, the voice audio will be captured and divided into chunks of 20 milliseconds and use the negotiated codec to compress the data and send it on the IP network. So each RTP data unit in the trace actually includes 20 milliseconds of talk time. In other words, if 3 packets carrying RTP got lost, you will miss 60 milliseconds of the actual voice data. And that brings us to audio issues like jitter and choppiness, especially when there is a network that suffers from congestion. I mean, basically we get these type of issues because packets carrying RTP either get lost or arrive out of order. And another thing about RTP is, you know that SIP, some of you might know that SIP uses port 5060 by default. RTP usually uses a different port. Let me go back here to the same trace so I can show you something. If you look at the media description, name and address, it has the audio, and then next to it, it has 5008. This is how the device sends the RTP port that the remote or the recipient needs to use to send RTP. So RTP and SIP, just to summarize, they use different port numbers. RTP also is used in conjunction with RTCP, which provides statistics, and QoS. Codec, voice codec. So let's quickly define what codec is. Basically, codec stands for coder decoder because it encodes the audio signal that you send to the phone through the handset into compressed digital data to be sent on the IP network. On the other end, the recipient must use the same codec to decode and decompress the voice data back into audio signal. This is why when there is a mismatch of codecs in the SDP message or the SIP message, the call will automatically fail. So Grandstream devices support the major codecs used in the VoIP industry, and I'm going to explain them, go through all of them right now. So these are only few, 5. We support, I believe, like more than 10. So these are only like 5 of these codecs. You don't have to master how they work, but having a basic knowledge about them will help you make a good decision about which one to use on your devices. So the one that is used by default on our devices as a top priority is the G711. This one uses the 64 kilobits per second for one-way audio. Because this one is not highly compressed, it uses less resources from the CPU. Next, we have the G729. This one is highly compressed and uses 8 kilobits per second. This one makes it excellent for bandwidth because it uses less bandwidth, but at the same time, it's more resource intensive because to run the compression that requires running the algorithm, which also take resources from the CPU. The Grandstream devices, we do support G729. One thing that you should know about G729 is when you initiate a conference call from the phone, G729 does not allow you to initiate a conference like a 3-way audio conference because the license that comes with the hardware supports only one active call at a time. So be mindful when you about that when you use the G729. Then we have the G722. This one allows for bit rates of 64, 56, and 48, whether it's wideband or narrow band. Since all our Grandstream phones are HD, G722 gives you better quality, a better audio quality compared to the other codecs. So in case you want to get take advantage of the HD quality on the phones, you want to go with the G722. Then you have ILBC, which operates at 15 kilobits per second. And the last one is the H.264, which is the industry standard for video compression. So when you send video on Grandstream devices, you are actually using the H.264. So we talked about how to get the signaling messages encrypted using SIP over TLS so that no one know the metadata related to the call. However, when using RTP, anyone who has access to the network can capture the audio traffic on the wire and just listen to the phone conversation. So to secure the RTP traffic as well, SRTP needs to be enabled on the devices. SRTP uses advanced encryption system with 128 bits and 256 bits. The crypto key is exchanged in the SDP message, as you can see in the screenshot or the capture. That's why we always recommend when you use SRTP to use it with secure SIP, because if you just encrypt RTP with SRTP and you leave it and you're still using the text-based SIP, anyone who captures the traffic, they can use the crypto key to decrypt all the SRTP traffic.
Hey, Abdel, quick question for you.
Yes, sure.
Rich writes in, so if the G729 codec is being used and you make a conference call, does it switch to a usable codec?
I mean, if you have, for example, let's say you have the phone configured with multiple codecs and you have G729 as the primary one, the first call is going to use G729. If you want to initiate another call, and because there are other codecs, you will still be able to use another codec in the conference call. But the thing is that make sure that the server also supports other codecs, because as I mentioned, the codec on the SIP endpoint and the UCM, they need to match for the call to complete. So if you have multiple codecs, that should not be a problem. But if you are strictly using G729, that would be a problem. This is not going to allow you to initiate a conference call.
Perfect. Thank you.
So SRTP on the Grandstream devices can be enabled using two modes. Enabled but not forced, which means I can enable SRTP on the devices, but if my phone is talking to another SIP endpoint that doesn't use SRTP, the call will still complete. But if you choose enable and force on the SIP endpoint, that means that phone will only talk to the devices that use SRTP. If another device is not using SRTP, the call will not complete at all. And few more things about SRTP that you need to be careful, because we all like to take advantage of the good stuff like security that SRTP provides for us. But this comes with a drawback, and one of them is SRTP is resource intensive. So when you enable SRTP on the UCM, for example, that will take a lot of resources from the UCM. So if you have UCM that supports, I would say, 200 concurrent calls with SRTP, that number can drop significantly because all the resources were taken to run the algorithm for SRTP. Also mentioned, if you chose the mode enabled and forced, both devices, they must support SRTP for the call to complete. And another drawback is it's not easy to troubleshoot. So when you have SRTP and you're trying to troubleshoot an audio issue, there's a long process that you have to go through, which means get the crypto key, go to Wireshark, take all the encrypted traffic and use the crypto key to decrypt the traffic back to its original text-based traffic. All right, so I'm just going to jump to one of our UCMs and the GXP phone to quickly demo how you can enable TLS and SRTP. So I'm going to start with the UCM. So for TLS, you can enable it. You go to PBX settings, SIP settings, and TCP TLS. I'm not sure if you guys can see. Let me. Give me 1 second. Let me stop this. All right. Hi, everyone. All right. So to enable TLS or SIP over TLS, you go to PBX settings, then SIP settings, and you go to TCP TLS. So for this UCM, I have TLS enabled. By default, it comes disabled. And when you enable TLS, by default, you use port 5060. And this is the part that is important, is the upload of certificates. So when you try to, the UCM comes with built-in certificates, by the way. So if you want to use the built-in certificate, you don't need to upload any certs. You can just use the ones that come with the UCM. But if you have your own CA and your own certificates and you want to upload them, there are 3 types of certifications that you need to include. Because TLS provides you with two-way authentication between the 2 endpoints involved in the call dialogue. So both the UCM, let's say, and the GXP will use the TLS certificate to authenticate each other. So the first one, you have the self-signed certificate. This one, it's going to be used for authentication. Then you have the TLS cert. This is pretty much the public key. This is the key that the UCM will send to the other party or the IP phone, and the IP phone will use the provided key, which is this one, to encrypt the traffic, then send it back to the UCM. Then the UCM will use the TLS key or the private key to decrypt the data. That's why you need
Hey, Abdul,
three sets.
real quick.
Yes.
We had a couple of questions come in. Two were related to why the TLS do not verify is checked. And then Kurt wrote that he thought TLS requires TCP. So two questions: why is the TLS do not verify checked, and does TLS require TCP?
Yeah, I mean, TLS runs on TCP, that's for sure. You should have the three-way handshake to open the TLS connection. But the reason I have TCP is just in case you want to run SIP on TCP without TLS. But when you enable TLS, let me enable now. So when you enable TLS, it automatically runs on TCP. So when you have that one, for example, unchecked, just to clear the confusion here, it doesn't mean that TCP is not being used. It is actually being used. It's just another option to enable TCP without TLS.
Perfect. Thank you.
You're welcome. So this is for secure SIP. Let me go back to the SRTP, or the secure real-time transport protocol. This one, you can enable it at two levels. You can enable it at the extension level. Let's say I have extension 1000. I'm just going to go to media. Then you have the option here, SRTP. And you have the other two options that I explained in the slides. You can enable it and force it, which means this extension will only talk to other extensions that support SRTP, or you can enable it, but it's not forced, which means if another extension is using SRTP, they're going to go for it. If not, they're just going to use regular, like the traditional RTP, the plain text RTP. You can also enable SRTP at the trunk level. So you just select your trunk, then you go to advanced settings, scroll down, and you're going to see SRTP, which is disabled by default. So if you want to enable SRTP at the trunk level, make sure that your carrier is also using SRTP. Now go into the phones. So I have a GXP phone here that I can use. Okay. Let's talk first about SIP TLS. Let me go back here to maintenance, security. So as I said, all the Grandstream devices, they come with built-in certificates. If you want to upload your own certificate, this is where you need to do that. In case you would like to check this option, validate server certificates, you need to upload the trusted CA certificates on from the web UI of the GXP phone, so that the GXP phone can use those CA certificates to verify the authenticity of the CA sent by the server, for example. So when you create an account, let's say I have extension 1005 and I would like to enable TLS for that extension. I just need to go to, let me go back here slowly, select the account, then go to SIP settings, basic settings, and then I can select TLS TCP. If I just want to use TCP by itself, the same way I explained on the UCM, I can just click on TCP. But once you enable TLS, that's automatically you enabled TCP. So when you do that, save and apply, the GXP phone will start using the TLS to make and receive calls. Then we have the SRTP. SRTP, you need to enable that one under audio settings. So when you go to audio settings, you have the option to choose SRTP. So you can enable SRTP and force it, or just, for example, enable it but not force it. The phones by default are configured to send the crypto key using both 128 and 256 bit, but if you just want to use 256 bit for more security, you can choose that one under the SRTP key length. And another thing, since we talked about codecs, this is where you need to change the codecs on the GXP phones. By default, we have 8 codecs enabled. This is good, but there's also one drawback when it comes to enabling so many codecs on the phone. Because as I mentioned, when this phone is going to send an invite, it's going to send information about all these codecs configured on the GXP phone. So when you include more information in the SIP packet, that increases the size of the SIP packet. And sometimes it can exceed the maximum transmission unit on the MTU, and you're going to start experiencing issues with the IP fragmentation. So if you would like to avoid that issue, I would recommend to choose 2 codecs that you can enable on the GXP phone so that the size of the SIP packet does not get too large for compared to the supported MTU size of your router. So for example, if I'm going to use PCMU and G729, I can just choose all of them as G729. This way, when the phone sends an invite, it's going to send only 2 codecs in the invite message. You can do the same thing on the UCM. You can go to the VoIP trunk under advanced settings, and you can only select this one and just remove all the others and use only PCMU or G722, whichever codec you're comfortable with. So this is it for the presentation. If you guys have any questions, please feel free to submit them in the Q&A area. And John is going to help ask you questions, and we can provide you with the answers.
Yep. So we did have, so one guy wanted to confirm, why was the TLS do not verify checked to start with? I'll let you answer that one first, and we kind of go from there.
Is he talking about, this is the thing, as I explained. Let me go back here again one more time. So as I mentioned, by default, it's not checked because, as I said, if you would like to check that one, set it to yes, you need to go first. Before you do that, you need to go to this page and upload the CA certificate or the trusted CAs that the phone is going to use to verify the authenticity of the CA sent by the server. Because the GXP doesn't come with uploaded trusted CAs, that's why it is disabled by default, but you can enable it if you have trusted CAs uploaded on the GXP phone.
I'm sorry, on the UCM, not the phones.
The same thing, I mean, the same principle that I mentioned on the phone applies to the UCM. Let me go back here one more time. Do not verify. So if you would like to uncheck this one, make sure you upload the trusted CAs and the choose file to upload. So it's the same principle on both the UCM and the GXP phone.
Got it, got it. Let's see. The SIP URI scheme when using TLS.
What was the question again, John?
Let's see. Let's go back to that. Where'd it go? This It says, how about the SIP URI scheme when using TLS?
What about it?
I'm not really sure. Athanasios, if you can expand upon that question. He also asked, how can we download those certificates from the UCM in order to import them to the GXP phones?
Now, those are, as I mentioned, those are built into the UCM. The ones that come with the phone, they're compatible, so that should not create any problems for you. But in case something happens, I don't know, things can happen with electronic devices, and you need to have those certificates built into our devices. You need to open a ticket so someone can send you those certificates. Usually it's a PEM file that you can upload to the UCM or the GXP phones.
Okay, so going back to that SIP URI scheme, should it be active or not when using TLS?
Yeah, that one, always leave it active. It's enabled by default, so just leave it the way it is.
Okay.
I believe he's referring to this one right here. This one right here.
Yep, looks like question was answered. Let's check over here. If there are people trying to register an extension on the UCM from the outside, can they be blocked?
No, oh, he's talking about ROG extensions, right?
Yeah. Mm-hmm.
I believe he's talking about ROG extensions or malicious devices trying to register to his UCM. So when you go to the UCM, let me go back here, and you enable TLS. Even if you have devices that do not support TLS, they can still register to the UCM. So for your case, if a device is still using plain text SIP protocol to register to the UCM and they have the right authentication, they will still be able to register even if TLS is enabled.
Let's see. Is the TLS.key field for the private certificate?
Say that one more time, John.
Is the TLS.key field for the private certificate?
Exactly, that is correct. That's the private key. So when you have it named the private key, you're going to use the TLS key.
And built-in certs, is the CA cert also there? Let's see if that was...
Yes, I mean, there are two types of CAs. Just to explain them briefly. There's the self-signed CA. This one uses its private key to sign the CA. Then the device is going to send the public key with the self-signed CA for the device to authenticate it. But the one that I was talking about, excuse me, under the GXP phone with trusted CAs, this is when you have a third-party entity that validates the CAs. For example, using RSA, you have certain CAs issued by RSA. For that case, that's when you need to go to the phone and upload the CA. But answering the question that you just asked, the self-signed CA is already in the devices. Unless you want to use a third-party CA, that's when you need to upload it to the GXP and the UCM.
Perfect. So I think that was it. Thanks everyone for a lot of awesome questions. That was great. Love the participation. If you do have any questions after the presentation, feel free to email me directly. We can get on a call. Either I can answer it or we can get on a call with Abdel to get that answered for you. Some people asked regarding the presentation if it will be mailed to you, emailed to you. Yes, it absolutely will. Give us a couple of days to kind of put everything together, but you should be expecting a recording of the presentation here in your email. So that is all we have today. Abdel, thanks again for your time on this one. One more chat came in. Let's just make sure that let's see. One question from Marty. Since we are talking about security, we see many armpits to register unauthorized extensions. What is a good strategy to stop them?
I think that's going to be a different topic. There are a lot of things to talk about that one, but this is one of the things that I'm going to show them to you. So one of the first things, when you create extensions, you go to media. There is one feature here that we call strategy. If you have all the phones within the same subnet, which means your local area network, I would go ahead and enable this one and specify my subnet. So when you make that change, that means any device that the SIP registration comes from a different IP that is outside the subnet network, even if it provides the correct password or SIP password for authentication, the UCM will reject the registration because the SIP registration request is not coming from the local subnet. So this is one of the things that I would recommend for you to enable on the UCM. The topic of securing the UCM, that's another topic, and hopefully we can schedule a webinar sometime in the future just to focus on that topic.
Cool. Yeah, that sounds great. All right, awesome. Well, thanks everybody. I don't see anything else here in the chat. So once again, my name is Jonathan, Jonathan Garbin with VoIP Supply. Got a lot of great comments coming in, Abdel, about the quality of this presentation. So thanks again for everything you're doing this one.
All right, thank you, John, and thanks everyone for joining us in this webinar. Thank you.
Thank you. Bye-bye.